All right, let's get going. Welcome back, everybody. It's good to see everyone. Um, Today's lesson is on string algorithms, and really the heart of the material that was covered today is on solving problems with strings. And so I really don't want to kind of preempt those walkthroughs, since I want you all to go through them on your own time. So today, what did we do? Oh yeah, okay. So I'll talk a little bit about the first few, odds and ends that we got through at the top of the lesson. But when we get to the part on string algorithms, I'm just going to kind of let you guys ask questions. So I'd be happy to go through old homework problems. I'm happy to solve a different problem than the one that's, than the ones that are solved here. But I don't want people to skip today's walkthroughs because I think they're actually really important. And one of them is really neat. One of them is actually working with data in a string that's structured in a format that you would actually find in the wild, that you might, find if you were doing some data analysis or whatever. So that's I think a fun thing to go through. And it's actually not that hard to work with data in that format once you have some sense of what strings can do and how you can use some of those features to your advantage. All right, so let's get started. So the first couple things, and as we go forward, typically what we'll do is we'll introduce concepts in the most straightforward way that we can, like when we talked about types and how we assign different types of variables to each other. And then we'll come back, maybe a little bit later after you've had a chance to kind of absorb the core idea and talk about some of the special cases and the exceptions and things like this. So, when we first talked about variables and types, we pointed out that Java will prevent you from assigning a literal value, right? In this case, so the literal on the right side of this assignment is a double. It's got a decimal point. By default, in Java, anything with a decimal point is a double literal. Anything without a decimal point is an integer literal. We know that we have these different suffixes that we can use. So if I want to make this a float, that's how I would do it. If I wanted to make this a long, that's how I would do it. But it's not really that important. So here, this is a double literal, and I'm trying to assign it into an int variable. And when I run this, I'm going to get an error because Java is, explaining to me that I can't do this, right? This is not okay. I need to assign when I do this. The reason I can't do this is because there's information that's potentially lost, right? So in order to fit that double literal into an int container, Java would have to discard information. It's not going to do that. Now, you might think, well, why is this machine, resisting me, right? You're in charge, right? You're the programmer, right? And so in this case, there is a way to force Java to do this. And there are times when this is appropriate. There's times when, you really need to do this. And the way that you do this is to use to apply what's called a typecast. So I'll show you an example of this. To apply, the typecast goes over here on the right side of the assignment. And so what this is doing is it's saying to Java, I force you to assign this double literal into this int variable. And I'm willing to deal with the consequences of that decision, right? And what the consequences are, as you see, is that decimal component that I had in the literal has been lost. So, I took something that was an int, that was a double that had some fractional information, and I assigned it into an int container, and I was able to do that because of the typecast, but I also lost information. And so this syntax, and this is new, I have the name of a type inside parentheses, and that goes on the left side of the thing that I'm casting. And I can cast the result of a mathematical expression. So here, now we have to understand what's happening. So the cast is being applied to 10.8. And then I'm trying to add it to another double value. So if I want to cast the result of this mathematical expression, I need to do this, and then it works okay. Casting is sort of inherently dangerous because you're forcing Java to discard information. And so that's why I have to use this more explicit syntax in cases when I want to do that. Okay. The other quick thing to point out before I start taking questions is that Strings in Java have this interesting feature, which is that the contents of a string, all those methods that we called on strings, they never modify the contents of the string. So I can reassign a string variable, right? So I want to distinguish between two things. So for example, if I say second is equal first dot repeat, this is one of these kind of fun string functions that repeats a string 2 times. You'll see that I get what I expect. I have the string repeated twice back to back. But first doesn't change. First is still the same value that it was originally. So none of those string functions, those string methods that we've started to use as part of our programs, that we can access because strings are objects, and so we can access them through dot notation in the ways that we described in the last lesson. None of them modify the contents of the string. Instead, what they do is they just return a new string. I can reassign the contents of a string, so I don't want you to think that strings can never change. If I do this, then you'll see that what I've done is I've reassigned first, right? So just like other variables, once I create a string variable, I can reassign it, right? So I can assign other content to it as I want. Okay, so those are the two little bits of new information about Java that we led off with, and when the lessons are really again set up to try to kind of emphasize what's important about the language as we go. So if there's something that's not covered in detail in the lesson, you can assume that it's not necessarily going to be a big concern for us. They're not going to be like 10 questions on a quiz about it or whatever. These are just like little bits of information that you need to know because you will see this stuff in the wild, right? And there's times when you need to use this or you need to be aware of this information. All right, so like I said, below this, there's 2, I think, really interesting walkthroughs going through different string algorithms. And again, I don't want to ruin these for you, so I'm not going to go through them. Let me just reset this one. Reset this. No, this one's already reset. So yeah, so I'm not going to go through these in detail. Instead, I'm going to let you go ahead and go through these on your own time. And so let's see here. Yeah, for loop to parse through a string. Yeah, great questions. So the question about EMP, let's move down to the forum. I don't think graduate students can register for EM. Well, I don't know. Try it. I don't have, one of the things that seems to be a common misunderstanding about my role in this course is I have no control over registration. I cannot register you for a course. I cannot unregister you for your course. I have zero control over that. So people come and they're like, can you help me switch labs? And I always have to say no. And it's not because I don't want to, it's because I can't. Like, there is no button that I can push that will cause you to switch labs or be in a course or whatever. You have to work that out through the existing systems that the university has and in conjunction with your academic advisors, who are usually the people to talk to about stuff like that. Is there any scenario in which one can use a for loop to parse a string? Sure, yeah, absolutely. So I mean, if you go back and if we look through this string character search, that's an example where we do use a for loop. Now you have to think a little bit, like when I'm using a for loop to go through a string, what am I typically doing? Well, usually what I'm doing is I'm examining characters in the string, but I could also use a for loop to look for something else. So that actually kind of, that's a nice segue into kind of a fun example. So let me go up here to this playground. I'll wipe out this. And let's do a little example of something that we could do with a string and a for loop. Let me pull up the string documentation because the function I want to use here is substring. Okay. So and let's check out what substring does. So let's write a method that does use a for loop to go through a string. And in this case, we won't convert the string to an array of characters. Sometimes when you're using a for loop to parse a string, one of the first things you do, and you'll see this in one of the examples in the lesson, is use one of the string methods to take the string and to convert it into an array of characters, because now I have an array that's something a little bit more natural to use with a loop. But I don't have to do that. I can also there are string methods that allow me to pass an index. And so there's other ways to go through strings using a loop. So let's do this. Maybe let's write a void method that print all pairs. This takes a string as input. And what I want to do is I want this method to print all pairs of characters in the string, right? And so I'm going to call it print all pairs, and I'll pass test. And when I call this method this way, what I want it to do is I want it to print TEESST. Fair enough? Kind of a fun thing to do. So let's figure out how to do that. So the first thing I need to do is I need to actually write a loop that goes through all of the valid positions in the string, right? So loop through all positions in the string. So that's going to be the first thing we're going to try to do. This string that I'm testing with is 4 characters long, so it has 4 valid positions, which would be index 0, 1, 2, and 3. And so on some level, this for loop looks a lot like the ones that we've written for arrays. Remember, with an array, we have this dot length property that we can use. With the string, it's a method, but it's still there. And so we can write a for loop that looks very similar to the ones that we've written to go through arrays. The only difference is that rather than using the dot length property, so if this was an array, it would look like this. If it's a string, it looks like this. This is one of the things about Java that doesn't make a lot of sense to me. I wish that they would have been consistent about this, but they weren't. So this is what we have. So let's see if this works first. Okay, 0, 1, 2, and 3. So that's great, right? And again, whenever we start to write our programs, and I would encourage you, this is something that I do when I write big pieces of code, right? You start with little things, right? These are little sanity checks. Sometimes I like to tell people and maybe there's some general law of programming here. In any number of lines of code you write, you're going to make some number of mistakes. And like I said, I mean, this number may go down over time, although I'm not sure it goes down that much. What happens is you get better at fixing them, and so they become less of a problem. But you just assume that if you write, some number of lines of code, you're going to make some number of mistakes, okay? The problem with mistakes is that problems with your code compound each other. So, it would be great if 2 mistakes with your code was twice as big of a problem as 1 mistake, but that's not how it works. 2 mistakes is like 4 times as much of a problem. 3 mistakes, it's like at least exponential, if not some sort of factorial growth. It's bad. So you don't want your code to have more than 1 or 2 mistakes, because as soon as you have like even 2 sometimes, or 3 or 4, what happens is they interact with each other in weird ways, and you're trying to fix one, you realize something else is broken. And so if you can make sure that your code only has 1 mistake in it at a time, and it will have a mistake. I mean, again, like I said, that never goes away. So get used to it. That's a part of being in this field, and writing computer code is making mistakes and fixing them. And, at the end of the day, you get to build really cool stuff. So that's the pro, right? The con is that you do spend your life finding bugs and fixing them. That's okay. But if you can avoid having more than 1 problem with your code, it's a huge, huge, huge help. And the way you do that is you work incrementally. You write a little piece of the code, make sure it works before you move on. Because the more of the program you write without really understanding whether it works or not, the more likely there is more than 1 problem going on, and then you're in trouble. Okay, so now I have this. So just for fun, why don't we do the first thing? We'll print 1 character at a time. Eventually, I want to print 2 characters at a time. But let's just probably print 1 character at a time first. To do that, I need to go back to my string methods, and I need to, there's this toChar array method. But when we talked about this, we also pointed out that there's a method that returns a character called char at, and that takes, as you see, an index. So this will give me the character at a particular position in the string. So instead of just printing I, what I'm going to do now is going to print input.char at, and I'll pass I as the position. And now you see 1 character on each line, TEST. Again, I could have done this with a character array, but I don't need to, because char at takes a position in the string and hands me back a character. So I could have converted this to a character array first and then gone through it as an array, but I can also do it this way. They're equivalent on some level. I wouldn't say one's better than the other, just different. All right, so now I want to print pairs, okay? And so here's where things get interesting. So, T is the character at position 0. And when I is 0, that's the character that's being printed. So if I also want to print the next character in the string, remember my goal is to print TEESST. Then I should print input, and I'm going to use string concatenation here because essentially I have two strings. Char at I plus 1, right? So this should work. So, T is a position 0, E is a position 1. So now the first time through when I is 0, I'm going to print the character position 0 and the character position 1. Second time the character position 1, third position 2. Okay, so this is going to work great. Let's try it out. Oh, okay. So I've got actually a couple problems here, and let's talk through them one at a time. The first thing is that my output is messed up, and I'll talk about why in a minute. This has to do with how Java handles characters, but we'll get there. But let's fix the second problem is more serious, which is that my code has crashed, right? I see, if I go back to the lesson that we did on error messages, I see an error message here that indicates that something went wrong. And this is, we've seen these array index out of bounds exceptions when we've worked arrays, when we've walked off the end of an array. With the string, we have a similar error message that can be generated. This says string index out of bounds, and it says string index out of range 4. And based on what got printed here, it looks like this happened the last time I went through the loop. And so to see what's happening here, so 4 is not a valid position for the string, right? The string has 4 characters. The valid indices that I should be able to pass to char at are 0, 1, 2, and 3, right? Okay, so what's going on here? Let's think about what happens the last time I go through the loop. So the last time I go through the loop, I is 3, because when I gets to 4, this conditional expression will no longer evaluate to true, and the loop will stop. And I'll drop out of it, and this is a void function, so I don't need to have a return statement, and the function will just exit. The problem is the last time through the loop, I is 3, right? So this works fine, input char at I, that gives me the last character in the string, but this does not. This is where I've created this problem where I'm trying to use an index of 4. And so the thing that's, and we'll come back to this because we'll do other problems where we go through pairs of things, because it's kind of a fun way to go through arrays. Here's the thing to keep in mind. If your array has n elements, how many pairs of elements does it have? Adjacent pairs, right? Well, think about it. My string is TEST, TESESST. It has 3 pairs of adjacent elements. If it was the string wow, it has 2 pairs, WOW. And so if my string has n elements, it has n minus 1 adjacent pairs. And so what I need to do is I need to adjust my loop up here to only go up to the end of the string minus 1. Okay? And so now if I run this, it doesn't crash from problem because the output here, what is going on? So let me try one way of fixing this, and then we'll see if that actually works. Okay, it did. Let me explain what's happening here. So input.charAt returns a character. This also returns a character. So the two sides of this plus statement are characters. They're not strings. We talked about how we can use the plus concatenation operator to concatenate strings. But the thing that's weird about Java, we've seen this before, right? So if I say char first is equal to x, char second is equal to y, and I print first plus second, again, I see, well, let me comment out the call to this method and just make it simpler. I see 241. So what's going on here? Well, this is one place where I feel like the Java language is fundamentally broken, because here's what it does. So Java sees a character, and it sees a character on the right side of this plus sign. So character on the left, character on the right. Java knows that it can convert a character to an int using that table that we talked about, because to a computer, everything is a number. And it sees an addition sign. And so what it does is it says, it essentially automatically converts both sides of this to ints, and then it adds them together. And so what you end up with is a number that's the result of adding the character code for X and the character code for Y. And again, if you went and looked back at that ASCII lookup table that we keep using for some reason, you'd find that the character code for X plus the character code for Y would add up to 241. So that's not what we want Java to do here, right? We want Java to treat these as strings. And so here's kind of an interesting trick that we can use to get this to happen. Okay, so let's talk through this and think about how this works, because this is weird. What I've done is I've added an empty string to the front of this, empty string plus first plus second, okay? So, and figuring out how this works is sort of interesting, right? Because this kind of gets you into the mind of Java. So when Java starts, sort of going through this statement, it's working from left to right. And so it sees a string as the first part of this expression. There's three parts. I've got a string plus first plus second. And so it says, oh, okay, this is a string. And then it sees plus character. So when it sees a string and it sees a plus sign, so the fact that there's a string on the left side of this plus operator means that Java treats it as if it's string concatenation. So rather than addition, which is what happens if both sides are characters, as soon as there's a string on the left side, the meaning of this operator changes. And Java says, okay, well, I need to do string concatenation. And it says, okay, I've got a character. Can I concatenate a character to a string? Yes, I can. I know how to do that. But it also preserves the fact that this is a character. And so I can apply a similar trick up here, and everything will work. So yeah, that's a, no language is perfect. Java is not a perfect language. In fact, I would argue Java has many problems, but that's because I'm familiar with it. So, every language has problems. Every language has made mistakes along the way. To me, this is one of them. I do not think when you add two characters together in Java, it should automatically cast them to ints and return a number. That does not seem to be the right thing to do, but that is what the language will do. So it's just something to keep in mind. Again, I can't argue that this is a good feature of Java. It's just something that it's just a feature of the language that you should know about. Okay, I'm going to go through some other questions. So that was can I use the toString method and parse through it? I'm not exactly sure. Yeah, try to clarify that question for me, because I'm not sure what you would use toString on. You talk about what to consider when casting a type to another. Yeah. So, type conversions are kind of, I would say if you actually have to apply a manual cast. So the type conversions that Java will do automatically, with the exception of char, are almost always okay. So the fact that you can use an integer literal to initialize a double is totally okay. And you should just let that happen naturally and not get in the way. The only, and we've just run into this, right? The only place where you need to be careful is working with characters, but we rarely do that. You're normally working with strings when you're working with text. So when you work with characters, you need to think a little bit about why that happens. Otherwise, you end up with problems like the one we just saw. But in general, the automatic, so Java is actually typically pretty conservative about casting. It won't try very hard to convert things for you. And that's a good thing, because there's a lot of times when doing that automatically can cause problems that may be invisible to you. And so Java's approach is typically to basically throw up its hands and be like, I don't know how to do this, you gotta help me. If you need, there's certain places where you need to apply a cast, and it really depends on the data that you're working with and how you're working with it. Losing fractional information is sometimes okay. It kind of depends on the precision of the data that you expect to work with. So I'm trying to think of an example. I mean, if we were doing math with time, right? So let's think about time as an example, right? Time is something that computers typically count. Fraction. So typically, whenever you use a timer on a computer, what you get back is an int. It's some sort of count. Now, when you did the problem working with time and converting it back and forth from decades, right? What you notice is those time values are pretty big, and that's because those are actually milliseconds since 1970. So again, it really depends on your application, right? Milliseconds since 1970 is that accurate enough for the type of thing you're trying to measure? If it is, you're okay, right? That's a perfectly okay type of counter to use. Now let's imagine we're doing math with that, right? So let's say we have like some amount of milliseconds between two events and we want to divide it by 2 or something like that. Well, that might produce a fractional result, right? If I have an odd number of milliseconds that I divide by 2, I end up with a fractional result. In that case, discarding that little fractional component is okay. It's like, who cares, right? And actually, one thing to point out is when you do integer arithmetic in Java, this is another really interesting thing to look at. So let's create a variable called I. I'll initialize it to 30, and then we're going to print. Actually, I'll use 31. System.out.println I divided by 4, which prints 7, right? I divided by 5 is going to print 6. That makes more sense. 4, does that make sense? 3 is 10, right? Whenever you do division in Java, again, there's no integer division is not rounded. The fractional parts are just tossed, right? Try a better example here, right? So let's try something like, I don't know why yeah. So here's a good example, right? Well, actually, no, that's bad. Let's do this. Okay, so that's 0, right? I mean, 2/3 should round up to 1 if we were rounding, but we're not rounding. When we do integer division in Java, we discard the fractional component entirely. So again, the amount of precision, if you go on in the CS program, there's a course that you're going to take in a few years that's going to actually go into a lot of this in a lot more detail. It's going to talk about how numbers are represented internally in the computer. It's going to talk about different trade-offs with floating point numbers. We already saw that, right? We did, in the lesson, we pointed out that a floating point number can store really, 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 really small value. It can also store really, really, really big values, but it can't store a really, really, really big value and a really, really small part of that at the same time. Something gets lost. Typically, the small part gets lost. So there's always limits to this, right? And that's an important thing to understand as a computer scientist. There's no such thing as perfect precision. And there are applications where tiny, tiny little errors make huge differences. My favorite example of this is, trying to fly to the moon, right? If you're going to launch something at the moon, or much less like Mars, right? Now, obviously, you make course corrections along the way, but if you're going to launch something at Mars and you want to put it in orbit, shall we say, like a tiny, tiny little rounding error, right, that might normally never cause a problem in a computer program can cause your probe to crash or just miss the planet entirely and fly off into space, right? So, and that's because, like 0.0000000000001, the computer didn't think was that important, turned out to be like 5 miles, right? After you imagine that's the error in your angle and you're trying to shoot something at something that's, millions of kilometers away, it adds up, right? And so when you start working on those sorts of problems, there's actually really good tools and really good approaches for making sure that you maintain the level of precision that's required by those calculations. Because even small errors that might not normally trouble us at this stage can have big consequences. But it really depends on the type of data you're working with. All right, I'm going to take a break for a minute. I'll be right back. Come up with some other good questions to ask while I'm gone. people, this is high. All right, back to the Q&A. If you put the type of the variable in front of a number variable, it will make the number or become 10. Well, let's try it. So there's two things to keep in mind here when we're using typecast, right? On some level, there's the type of the variable, which goes on the left side of our initialization and assignment, and there's the type of the information that we're using to assign the variable, right? And this goes back to thinking carefully about two sides of the assignment. So I've got the right side of my assignment, and I have the left side of my assignment. And so the left side of my assignment tells Java what type of data to expect. It expects that this variable will always be set with double values. Then it looks at the right side of the assignment and tries to decide if what you've put on the right side of the assignment is something that it can assign to a double. So this works, right? I can assign a double literal to a double. This also works. I can assign an int literal to a double because Java can convert that for me, and it can do it safely. There's no chance that there's information that's going to be lost here. I can't do this, right? This will not work. And not only, so you notice there's a different error message. Before we got that, when we tried to assign a double to an int, we got this error message that there's possible that there could be data lost. So that error message kind of indicates Java knows how to do this, but it won't without you being more explicit about it. So that typecast that we apply is our way of telling Java, I'm okay with the consequences here. In this case, Java is saying, I can't do this at all. So this is a case where applying a cast, Java doesn't know how to do it. Java doesn't, by default, have a way of converting a string into a double. Now, there are methods that we can call that do this, and if you look at the walkthrough that's later in this lesson, we talk about how to do that for integer values. So, and this is really common because we'll talk, in that walkthrough about a lot of the data that you find out in the world essentially comes as a string. That's how you get it. Like somebody, gives you a file, and inside that file is really kind of one long string. And so converting parts of that string back into numeric values that you need to do calculations and stuff like that is something that there are ways to do this in Java, but by default, Java doesn't know how to do this. And that goes back to the question someone asked a minute ago, which was a great question about, when do I know when I need to use a cast? Like I said, Java's very conservative about this. As a language, it doesn't do characters, which again, I don't understand. But in general, it doesn't do very much to help you out. So you might think, and there are other programming languages that would allow you to get away with this, where they would say, okay, well, let's see. I've got a string over here on the right, and it's just character values, and so I bet I can know how to do that. I'll convert it into a double for them, right? And there's probably programming languages that would do this for you automatically. Java won't. Like I said, it's more conservative. So there are ways to do this. Let's see here. I think it's called double.parse double. Will this work? Let's try it. There we go. Yeah, so that's how to do it. There's a method that will take this string and convert it into a double. So this is a method that we're calling. And again, we use something similar in the walkthrough, but for ints. So this is a method, and we'll talk about why this method has this syntax a little bit later in the class, and that'll make more sense to you. But what it's doing right now is it accepts as its only parameter a string, and it tries to convert that string into a double. Now, this may not work, right? So what if I do something like this? Okay, well, now I have a different type of error that's occurred when I tried to execute this program, and that's because the algorithm that is represented by this method doesn't know how to parse this particular string. And of course that makes sense because I could say, I could put stuff in here that it's clearly like this is not something that I could convert to a double. So again, Java won't do these types of conversions for you automatically. Instead, there are functions and libraries that you can use to do them when you need to, but I can't just apply a cast here, right? I can't just say double that won't work. So hopefully that addresses the question a little bit. Other questions on this material or on old homework, whatever. I'm more than happy to answer questions, to talk about whatever you guys are curious about, or if there are no questions, I'll hang out a minute. I know there's a little bit of a lag on the stream. So I'll hang out for a minute or two. Part of being a professor is getting good with awkward silence, which is even more awkward because I'm all alone here by myself, just talking into the green light next to my webcam. Anyway, stick around if you have a question you want to ask. I'll hang out for a few minutes to see if people do have anything that they're curious about. All right, everyone. I think we will call it a day. Thanks for joining me. As always, if you have questions, please join us on the forum. The help site's been really active. We have lots of staff there available to help out if you have questions. And of course, we have our daily sessions still going on as usual. So I hope to see you guys around, and I'll be back tomorrow.